This video goes through several exercise questions to illustrate how to use set builder to describe strings and how to use set operation to manipulate strings. Firstly, let's clear up some definitions. Within computer science, when we say a string, we meant a sequence of symbols from a non-finite alphabet set. And please pay attention to this word, a sequence. It means order doesn't matter. So if you got string AB, it's not same as a string BA. Now, based on definition of string, we further define what do we mean by a language. A language is a set of strings, which means we have a collection of strings and put them together and make a language. So you have a lot of strings and then form a language. And be careful, we're using word set here. Within set, order doesn't matter. So if you have set A and B, right, would be same as if you put in the different order. Now let's start work on our questions. Question 1. Write down the first few strings of the following languages. We have two set builder here. Let's work out them one by one. First one, look at the pattern. It says you repeat 0, 1 to n times. Okay, 2n here means 2 multiplied by n. Just make notes here. What if 1n is 1? What if 1n is 2? N is 3, etc., etc. Obviously, 1n is 1. We repeat 0, 1 twice. 1 is 2 is 4 times. And 3, 6 times. So on and so forth. Let's answer. Our second question looks a little bit more sophisticated because we have two little variables appeared instead of just one. It says repeat 0 n times, repeat 1 m times, such that both n and m start from 0, greater than equals to 0. We should think of the shortest string first. So any possible to have a string length of 0? Yes. When both n and m are nothing, 0, definitely we will get 0 to 0, 1 to 0. That means you repeat 0 0 times, 1 0 times means nothing. So really that means you should have an empty string. Empty string is represented by lambda. So now, what if when n is 0 but m is 1? We get 0 to 0, 1 to 1, which means that's a lambda followed by 1. If we already have some character, we don't really need to represent lambda, so we delete that. Next, how about change n is 1, make m 0. Okay, then we get 0 and without 1. Let me just write down remaining strings a bit more faster. We could have 0 0 and 0 1 1 1. Okay, that is all possible lengths of 2. And then for length of 3, you could have 0 0 0 0 1 0 1 1 1 1 1. Because they all have some 0 followed by 1. You never ever get chance like 1 0 0. No. Okay, that is impossible because it doesn't fit in this pattern. Okay, I probably don't need to write more. There's one thing I need to point out for this question is that answer like this, I show you. 0 1 3 0 followed by 3 1 4. What do you think about this answer? If you look at it, the all perfect string, those string here all follow the pattern we gave here. Okay, some zeros, then followed by some ones. But the problem is, in this answer, it indicates that you must have a same number of 1 and the same number of 0. But by definition, we didn't say m and n must be equal. This is not perfect answer, okay? Because you imply that n must be equal m, but which is not the case. Therefore, we need to be careful. We should cover various cases to make it perfect. Now let's move on to our second question. In this question, we gave you a couple of languages here. They're all small finite set. And we're asking you to work out what this new language is supposed to be. Okay, let's explain the definition here. Recall definition over two sets. We can do A dot B, which means product between two. That means all the possible combination pairs from two sets. So if you have A dot A, we can represent by A squared. So when we have cube of A, literally means you have 3A linked together. Okay, so this one, L, means we have 3A and followed by B, C, D, 3Ds, and 1E. What we mean is there is a new language. It's quite long. All the sentences in this language must have 3 words from A, 1 from B, 1 from C, and 3 from D, and finally 1 from E. Okay, that's the syntax. We need to verify those sentences. Which one is a legal sentence in this definition? I copied down here. In set A, we have Tom, Jerry, and plus the empty string here. So let's have a look. Tom is from A, and is from A. Jerry is from A. We got 3A. In B, we have E's and R. So this is from B, right? Then what's next? Very is from D. So we have this from D. This bit is from D. So where is the C? Doesn't matter. C can be lambda, so we can imagine there's a little lambda here. Invisible empty string. Okay, and then finally, happy is from E. Therefore, this is perfect match. So that's a legal sentence in this language L. How about next one? We have one from A, and the next one is from B. Now, in A, we have this little lambda here, which means we can put some invisible things. We have one lambda and another lambda. That's all fine, right? And after B should be C, so that is from C. And after C is D, we should have 3 Ds. E is this one. That's okay. Only problem is this. It's out of nowhere. It said at door, but that is not whatever in our definition. So I should have jumped to there straight away. Okay, next one. We have this is A, R is from B, and then very is from D. D I will write down here. And sad is E. So we have A and then followed by MT and B. Yeah, that's correct. Let's move to D. This is A is B, and not is from C. Sad from E. Correct. So next one, was is a problem. It's not defined anywhere. Okay, so we can immediately stop there. That is not. Finally, F, Jerry, A, B, very, so 3, D, and not is C, Z is E. What do you think about this? We have a problem with this order. Okay, so in the definition, C, you must have a C followed by 3 Ds. That's order. But here you got D, 3D, and followed by C. That's wrong. Finally, check if we remove lambda from C, which means current C we have lambda now, we change it to have this not only without lambda. So which of the sentence still be in L? The one has got exactly pattern. It's not in it, that one. Answer for this question, we should put that sentence here. Okay, now here's our last question. So we're giving you A, B, C, 3 sets. What's the result after you do the A square, B square, C square, and union them all together? Let's quickly work out what is A square here together. So A square should be A dot A, and I just copy what is A is here, right? So we literally do the production between these 2 sets. As the definition says, you should have all the combination between 2 sets. So really we should go for lambda, go with lambda, then will be lambda, and lambda go with A, would be A, right? And A go with lambda, A. Then finally A go with A, go to AA. And because we have 2 duplicates, so we just cancel one out. That should be lambda A and AA. So that's the result for A square. And for C square, as C is almost similar to A, just replace B to A. So we can simply just copy, yeah. Really same pattern. The last one is B square. We do all the possible pairs. One thing I need to point out is when we do set operation, we would put things like this. Write down. We have a pair, right? So AA and then AB, if you recall, when we learn set. But now here, we will just write down, ignore this bracket, not writing down them as pair, but using this way to represent string. Now come back to this question. We're simply saying the final language should be a union of everything. We just need to put everything together, that's all. But remove all the duplicate, if any. Okay, let's quickly copy. We have lambda, we have A, we have B, and then we have AA, and we have BB. And the rest of the thing we need to copy from here. Anything we have represent is this two, AB, BA. That's all. Next question. I already copied over that intermediate answer there. Okay, we are doing intersection instead of union, which means any common element between these 3. So what do we get? It got to be a common element in 3 of them. Answer is nothing in common between 3. The answer for this is empty. Okay, this have a curly brackets, open, close, mean nothing in it means empty set. The same as you just write down like this also means empty set. Our last two questions is about working out the difference between two sets. For example, difference between A and B. You work out something in A, but not in B. It's easy to use Venn diagram to solve this type of question. Okay, here is A square. We have a lambda, A, AA. And in B, we have A and B. Let's just shadow the area where we would be in A square, but not in B. That would be set. Satisfy that condition. Therefore, answer should be lambda AA. Then next, something in B, but not in A square. Something in B, not in A square. Answer is B. I hope that you find those exercises helpful. Thank you very much for watching.